so then sometimes we've got fractions as well. So remember, we can be dividing stuff. So here, this time we multiplied. What happens when you divide? What do you do with the powers? You subtract them, right? So it is the same thing. It's just going to look a little bit different. So what if I have, again, I'm going to give you all these screenshots, so don't freak out if you didn't get them all. I'm going to put them all up in a second. So if I get 10m to the power of 6, let's make it 7 so it doesn't simplify. 7/3 divided by 8 to the power of m a third. What am I going to do first? That's a 1. I'm actually going to rewrite it as a fraction first. Like, you're right, Shiris, that's exactly what I'm about to do, but I'm just going to rewrite it like this for my own sake because I prefer looking at it like that. But now you're right, I'm going to subtract my powers. Now the denominator's already matched, so I don't need to go through what we just did and make them match. They already match. So it's going to be m to the power of what? 6/3. And what happens to my fraction? Ooh. We're just going to simplify it, right? Because these are numbers, not powers. So how do I simplify this fraction? Yep, so I get 5/4. Okay, am I done? What else can I do? Oh, I'm so not. There's one more thing I can do to make this a little simpler. Ethan? Yeah, what can I do? No, so I don't necessarily need to put it in that form. There's something simpler I can do. You guys are overthinking it. Yeah, simplify the power. So what should the power be? Yeah, it's just 2, right? 6/3 is 2. So see how now I don't have any fractional powers at all. So there's no need for roots or anything like that because they disappeared. So sometimes the fractional powers will actually disappear. Sometimes they won't. All right, let's have a go at doing it in reverse. So what if I gave you the root version and asked you to turn it back into a fractional power? So let's say that I have, I'm going to have 8m to the power, oh, wait, no, other way around. Undo. I am going to do cubed root of 8m. Let's just do that. All right, who can tell me how I rewrite this back the other way? Kimberly, what am I doing? Sorry? 8m. Is that right? Am I good? There is something very slightly wrong with this. No? There's something missing. There's nothing wrong, but I'm missing something. Yeah, where should they be, Victor? Right. So the reason I need brackets here is because this whole thing was under the square root sign. If I didn't have brackets, I'm actually saying this. Right? That's what I would be saying without the brackets, but that's not what I wanted. So I needed to put brackets in to make that a true statement. So just watch that the other way around. All right, let's do one more of these. So what if I had the 5th root of w, and then I'm actually going to put this inside here. So what difference does that make? See how I put the 6 inside the brackets instead of outside? Sorry, inside the square root sign rather than outside. What difference does that make? Does someone want to have a guess what difference it might make? What do you think, Pradal?
One bracket.
Kimberly, what do you think?
Isn't maybe double to power 6 in a bracket with 1/9?
You know what? That is technically correct, but a very unnecessarily complicated way to write it. Aditya, you should know the answer to this. What difference does it make?
Sorry?
What difference does it make that I've got the 6 underneath the square root sign instead of like here where it was outside of it?
Oh, then it's just W. Then it's just wait, is that a W or an M?
It's a W, but it doesn't matter.
I'll go with M.
Okay, also
It's
this,
W. to the power of 6. It's not, cube, no, not cube, fifth root of W to the power.
It's the same thing. The answer is it makes no difference at all. Trick question. I actually did say this before. Remember when I said you can do it in either direction? You can do the power first or later. It doesn't matter where you write it. They're both true. It's just easier to do it when it's outside. It makes life easier, but it's the same thing. So who wants to tell me how I rewrite this with a fractional power? All right, Hannah, what do you got? 6/5, absolutely it is. Well done. All right. So I am going to let you guys have a go at this. Oh, actually, let's do one where it's both negative and fractional just to make you cry even more. Okay, what if I have 3m to the power of -2/3? Who wants to tell me how I can rewrite this and use roots? Kimberly, what do I do first?
First of all, use the 3 at the top.
Yep.
Over, m, squared.
Perfect. What do I do next?
3 over the square root of m, the cube root.
Cubed root of m. Perfect. There we go. Excellent, excellent, excellent. All right. So we can have negatives and fractions, and the whole thing is just all sorts of fun. All right. So if you are up to 2.9, keep going with that. That's just the negative stuff. If you finish that like most people did last lesson, we are up to 2.10, which is fractional. So you will notice that some bits in this textbook are purple. So if you have a look at 2.10, questions 1 and 2 are plain and question 3 is purple. When we talk about the purple bits, that's the extension part of the course. So we only sit the extension exams at KISC. So just be aware, anything highlighted in purple in this book is meant to be the really hard stuff. So if that's the stuff you don't get, don't cry too much about it. If you struggle with maths and the purple bits are just a little bit much, that is okay. We want you to get most of the course. You don't have to get 100% to do well. Ethan.
So we can try a little, not.
Well, we want you to try it all. It's just if those bits are the bits that you're really struggling with, that's okay, right? Yeah. All right. Okay, here we go. I'm actually recording all of this. So I'm going to put this up as a video. Okay, so all of me explaining all of that can go up as a video. I'll link to that on Google Classroom.